Hello everyone, welcome to the second video on Simulink model for electrical circuit. In this video, we will be discussing about single phase parallel RLC circuit. So if we look at this circuit on the screen, this circuit consists of resistance, inductance and a capacitance connected in parallel. So the specifications they are given. The value of resistance is 40 ohms. The value of inductance is 159.2 millihenry and the capacitance is 30 microfarads. The supply voltage is 230 volts and the phase angle is 0 degree and the frequency is 50 hertz. So for this particular circuit we have to implement it in Simulink, and then we have to find out the voltage drop across resistance, inductance, capacitance, and also we have to find the branch current, that is the current flowing through the resistance and inductance and the current flowing through this capacitor, and also the supply current. So let us go on to Simulink and let's try to implement the circuit. So for this circuit also we would need, the first thing we would need is the AC voltage source. Okay, so let's go into the library browser and find out the AC voltage source. So we are going to use this one. Now I would like to arrange the circuit in a slightly different manner. So I would like to rotate this. Okay, so one of the method I've told you is by right clicking and going into format, and then you will get the option to rotate clockwise or anti-clockwise. Another way is to select that component and click or press Ctrl plus R. Okay, so that's going to rotate the block. Again I will show the block name. Okay, and then I would like to connect my R, L and C over here, okay, above it. So let's look for series RLC. So this is the series RLC branch that we would like to use. And we first of all need the resistance and the inductance. So let's double click it and change the branch type to RL. Okay, and the value of resistance is 40 ohms and the value of inductance is 159.2 millihenry. So I'm going to put 159.2. Since the unit is in Henry, so I have to mention e to the power minus 3. Okay. Now, similar to the last circuit or the previous circuit, we had some issues connecting the, basically we cannot connect a voltmeter or a ammeter or your current measurement and voltage measurement between the resistor and the inductor. So what I'm going to do is copy it and paste it something like that, and going to change it to resistance only. Okay, and the next one can connect it. The next one should be inductance, right? The values are correct. So there we go. We have our first branch connected. Now the next thing is we need a capacitor. So you can choose a capacitor, but generally it might give you an error because a pure capacitor is not possible. So we need to have some resistance along with that. So it's better to choose RC, that is a resistance and a capacitor. We can select a value very small, let's say 0.003, and the value of capacitance is 30 microfarads. Okay, and now we can connect them. Okay, so basic circuit is now ready. Okay, now we have to connect several components to take the measurements. So we need to measure the current flowing in each of these branches. Okay, so we need a current measurement block. Okay, so we will need several of them. Uh, Now the first current measurement, I'm going to connect it here, something like this. Okay, and this one is going to measure my current through resistance and inductance. Okay, I'll copy that and paste it again, and basically I'll have to disconnect this part and connect it here. So this one is going to measure my current through capacitor. So I'm calling it I-C. Okay, I can zoom it a little bit. This should be okay. And I also want to measure the supply current. Okay, so let's connect. I need to rotate it. Something like that. Okay, so this is going to be the input side. So these are all the current measurements connected. Okay, obviously again this is a alternating current source, so I would need to take the RMS values. Okay, so I will need true RMS block, this one. I will need several of them to measure the RMS value between each of these. And a display. Okay, so we need to go down and select the one which can display the numbers. So this one. right? So I can connect it there. So this current is my supply current. Okay, now I can copy it, but before copying it I'll do a thing, that is I will change the fundamental frequency. So if you change some parameters and then copy that particular block, the parameters will also be copied. That means when you paste it, it will have the same parameter as your copied block. Okay, so I can select it and then paste it. So I'm going to delete this one and let's look for it. There it is. Uh, so how should we arrange it? We can maybe arrange one here and then again we can copy it and paste it. So this one is going to be the current through the resistor and inductor, like that. And this will be my current through capacitor. Okay, so I can connect this one something like that. Okay, and the capacitor can be connected something like that. Okay, now the next thing I need to connect is the I need to measure is the voltage drop across all these components. Okay, so I will need voltage measurement. I'll arrange these slightly differently so that I get some space down there. Okay, so now since I've arranged them properly, uh, let's take them here and let's connect this one something like that. Okay, right, so this is my voltage across the resistor. So let's call this as VR. VR is the voltage, and I can just again copy it and paste it to measure the voltage drop across the inductor. Okay, so this is my voltage across the inductor, VL, and also I need another one, and so I can connect this one across the capacitor. Okay, right, So this is going to be my voltage across the capacitor. Okay, and we also need to measure the supply current. So the last one, lots of voltage measurement blocks here. Let's call this as VS. That is my supply current, supply voltage, sorry. Okay, so we got all the four voltages. Okay, now again you can connect the RMS block and a display to check the RMS values of voltages. But again, similar to the last circuit, we are going to use a scope, an oscilloscope. Okay, just to see the waveform. So I'm going to use two of these oscilloscope. So the first scope, it will probably show me the uh, voltage versus the current, the supply voltage versus the current waveforms. Okay, so again it has a single input or a single channel. I'm going to double click on it and change the number of inputs to 2. Okay, the layouts I can select later on. So I need the current, the supply current. Okay, so I can just pull it down a little. So this is my supply current. Okay, and I need the supply voltage as well. Okay, supply voltage is coming out from there, right? And the second scope that I'll be using, it's going to display the voltage waveforms for the resistor, the inductor VL and VC. Okay, so we need 3 channels now. So again we need to change the number of input ports to 3. Okay, so we have the VR, the VL and the VC. Okay, all of them connected. And before we run the circuit, we need the power GUI block, right? Just place it anywhere you like. Let's place it here and just fit in all the blocks. Right, so the supply voltage is 50 Hertz. I haven't changed it. I need to change it to 50 Hertz. Okay, and the voltage is 230 volts. Now the phase degree or the phase angle is 0. So just in case if you are using a 3-phase supply, so you can use 3 of these AC voltage source, and each of them, they will have different phase angles. Okay, so I think I've changed all the parameters to 30 volts and 50 hertz. Okay, right, so the frequency is 50 hertz. Now I need, let's say this time, so one complete waveform will be of 20 milliseconds, as I explained in the last video. So this time let's check only 2 waveforms. Okay, so Let's change the stop frequency to 40 milliseconds or 0.04. Okay, now let's run the circuit. Hopefully, yeah, all of them, they are 50 hertz. Okay, let's run the circuit. Let's have a look. Okay, so the supply current, it's coming out to be 1.65 amperes. The current in the capacitor branch is 1.53 amperes, and the current through the resistor and inductor, or this first branch, it is 2.54 or 2.53 amperes. Okay, now let's have a look at the current and the voltage waveform. Right, so let's turn on the legends here. Usually the first input is yellow in color and the second input is blue. Okay, so as you can see, it is quite flat. The voltage across the or the supply voltage is yellow in color, and we can see it quite clearly, but the current uh, is not very clear. Okay. mm, right, so as you can see in this label, it's coming out to be IRL1. So since we have not changed this label, it's labeling it with the same name. Okay, so I'm going to change it to IS. Okay, and then again run it. There we go. Okay, so it basically takes up the name which you have given to this current measurement block. Okay, now one more thing I will do is I will change the layout. Okay, mm, so I can go into the configuration properties or that cog field and change the layout. Okay, now still the supply current is still not very visible, so just run it again and it should adjust the scale. Okay, now uh, again you can go into the properties, configuration properties, and you can show time axis label and display. You would also like to display the Y label, so let's call it as voltage. Okay, so if I click on apply, now you can see the labels. So active display number 2, also we need to label it. Okay, and oops, right, so this way you can check both the waveforms. Okay, now let's have a look at the VR, VL and VC. that is the voltage across all the components: resistor, inductor, and capacitor. Okay, so again we can use the current measurement, and we can measure the phase difference. Okay, so let's measure the phase difference between the resistor and the inductor. So it's coming out to be around 15 milliseconds. Okay, again, if you want, you can display the three waveforms, one below the other. Okay, and you can easily calculate the phase difference between each of the voltages. Okay, now let's go back to our slides and verify all these values. Okay, so I have already done the calculation, so we have to follow the same steps as the last circuit or in the first video. So first of all, we calculate the inductive reactance. We are given with all the values. So we are given with the frequency, it's 50 Hertz, and the inductance in Henry, it will be 0.1592. So that will come out to be 49.95 ohms. And using that value, we calculate the impedance. So then we can use this impedance uh, to calculate the current flowing in this RL branch, okay, using Ohm's law. So that value, it comes out to be 2.54, which is similar to what we have uh, measured in Simulink. The next thing is we can calculate the capacitive reactance using this formula, and that comes out to be 106.1. Now using that capacitive reactance, we can then calculate the current flowing in the uh, capacitor branch, again using Ohm's law. So that comes out to be 2.16. So again, I would emphasize that the uh, values or the measurements which we have got in the Simulink model, they are all RMS value. Okay, so we have to convert this into or find out the root mean square value of the current. So if we do that, we'll get 1.53 amperes, which is the same as what we have observed in the Simulink model. And uh, now using Kirchhoff current law, right, we can find out the supply current, right? So current flowing in to a node and the current flowing out of the node, they are the same. Okay, if we add them together, it's going to give me the supply current. So on doing the calculation and taking out the RMS value, we'll get 3.69 or 3.7 amperes approx. Now the next thing is the voltage drop across all the components. So again, using Ohm's law, we have already calculated the current, and we know the resistance or reactance values, so we can easily calculate them. So on calculating, we get the voltage drop across the resistor is 143.84 volts, and the voltage drop across the inductor, it comes out to be 179.62 volts. So I have not calculated it, but using the cursors, I have calculated it, but I have not measured it in the Simulink model. So you can use the cursors to measure those voltages. Okay, they should come out to be quite close to this value. And finally, the voltage across the capacitor, it comes out to be 230 volts. Okay, so this was all about this video. So this was the circuit on RLC, parallel circuit. We'll take up some circuits on three-phase in the next class, right? We'll try and implement some three-phase electrical circuits. Okay, so thank you so much for watching this video, and hope to see you in the next video.